Hello there. Let's move on to the next question. This question is based on HCF. Let's read the question. For any natural numbers m, n, and k such that k divides both m plus 2n and 3m plus 4n, k must be a common divisor of which of the following four options? So I'll first show you the jugaad, or you can say a competitive approach for such type of question. That is, the condition is given that m, n, and k are any natural number. So I'm just assuming m equals to 1, n equals to 1, and let's find k. So I'm just plugging the values. M is 1 and n is 1. So if I plug it in the given equation, the value is 3. And the second equation, it would be 7. Now k is a number that divides both these two equations, means k divides both 3 and 7. So k is the HCF of 3 and 7, and that is 1. Now which option gives you 1? That it would be my answer. So I'm just plugging this value in the first option. M1, n is also 1. So 2 and 3, which divides the number that divides 2 and 3 both, that is 1. So HCF is 1. Okay, it can be the answer. If I plug it here, 1 and 2, the HCF of 1 and 2 is 1 itself. Okay, I got two options correct. Means this value that I have assumed is not the appropriate one for the following options. Let's assume next value m is 1 and n is 2. So the value of m plus 2n would be 1 plus 4, 5, and 3 plus 8, that is 11. Again, I can see the HCF is 1 because they are co-prime numbers. 5 and 11 are co-prime numbers. So this data will not work again because the HCF is 1. So I have to assume some different value which will not give me co-prime values. Something different means I do not want k equals to 1. I want k equals to something different than 1. So this is not working. If I see the question, it is 2n. 2n is an even number. So I will assume m equals to 2 now, such that the whole equation will be a even. n and n equals to 1. So the value of m plus 2n would be 2 plus 2, that is 4. And here it is 6 plus 4, that is 10. Now I'm getting non-coprime and the HCF is 2. HCF of 4 and 10 is 2. So which option gives you 2? But that would be my answer. If I substitute it here, the value of m is 2, it is 4 and 3. The HCF is still 1. If I substitute it here, it is 2 and 2. Yeah, the HCF is 2. Okay, I'm getting 2 here. So it can be the option, can be the answer. If I substitute it here, it is 4 and 1. The HCF is 1, not the answer. And 1 and 1, the HCF is 1. So I got the answer, k equals to 2. In the second option, that would be my answer. So this is you can say a jugaad method. Okay. But the thing is, you have learned coprime thing and non-coprime. And here's how you have substituted the values according to the condition given to us. Now let's see the standard approach for this question. The approach would be something like this, that m plus 2n is a factor, is a multiple of k. That means it is some k times x. Similarly, 3m plus 4n is a multiple of k. It means k times y. Multiplying the first equation by 3, this would be the equation. And rewriting the second equation as it is, and subtracting them, it is 2n equals to k times 3x minus y. I can see that, it is 3x minus y. So I can see the k divides 2n here. So that is in the second option only. Right? That's it. I got the answer. Similarly, if I multiply the first equation by 2, it would be 2m plus 4n equals to 2kx. And that would be 3m plus 4n equals to ky. I subtract them. It is m equals to k times 2x minus y. Y minus 2x. Yeah. So k divides m here. And it is also in the second option. So this is a standard approach. And I hope both the concepts are clear to you. You can do this technique in any kind of equation if there is a condition given in the question itself. So you can assume the values. We'll see in the next video. Bye.